Section 2. Cloud Model and its Characteristics. Part 1. Cloud Model. In this section, we'll discuss models for categorizing cloud computing. There are many different ways to categorize cloud computing. The Cloud Computing Bible by Barry Sosinski categorizes cloud computing into the use model, which is based on the range of the service, and the deployment model, which is based on how it is organized. First, let's look at the service model, which identifies which layers of the infrastructure are to be served, and is broadly categorized into IaaS, SaaS, and PaaS. The pyramid in the textbook is an easy-to-understand representation of the cloud services model. The lower you go, the more control and customization you have over IaaS, and the less control and customization you have over PaaS and SaaS. Next, let's look at the service offerings for each model. IaaS is where the provider provides the networking, storage, servers, and some of the operating system, and you install some of the operating system, middleware, runtime, data, and applications on top of it. PaaS extends the provider's service offering up to runtime. Users only need to deploy the source code for their data and application. Finally, SaaS is where everything from networking to applications is provided as a service, which means users don't have to develop anything. Let's compare the process of building an app in an on-premises environment and a cloud environment. In a traditional IT environment, you must go through a period of configuring the network, introducing servers, installing operating systems, installing middleware, etc., and pay for the labor involved. However, with cloud-based services, you can save a lot of money and time in the deployment process because you only need to build a part of the environment, or you can get the application itself already. There are three general models of cloud service offerings, but there are also CaaS from a container perspective and PaaS from a function-centric perspective. Let's look at the characteristics of these 5 types. IaaS, which stands for Infrastructure as a Service, is a cloud service from an infrastructure perspective. IaaS includes virtual machines, disks, networks, and firewalls. An OpenStack is a typical IaaS. CaaS stands for Container as a Service and refers to services provided from a container perspective. While IaaS provides a virtual machine environment, CaaS provides an operating environment to run containers and container services. Users can just create an image and put it in a container and use it. A typical CaaS is Kubernetes. Next, PaaS, which stands for Platform as a Service, is a service model from a runtime perspective. It provides routes, apps, frameworks, web WAS, and a runtime environment for development, so that users can focus on development. A typical PaaS is Cloud Foundry. The fourth, FaaS, which stands for Function as a Service, is the cloud model from a service perspective. It means a service that provides the features you want to include when developing an application on a feature-by-feature basis. APIs, gateways, triggers, actions, and more, with Apache's OpenWhisk being a prime example. Finally, SaaS, which stands for Software as a Service, is a cloud model from a business perspective where you receive pre-developed software from a cloud server over the internet without having to download and install it. An example is Salesforce, which offers CRM software. The more you go with an IaaS model, the more flexibility you can create an app or build an environment, because there's more scope for user intervention. SaaS, on the other hand, provides pre-built software as a service, so you have less control and can only use the features that have been implemented. The illustration in the textbook compares each model of traditional IT and cloud environments to a mode of transportation. With an on-premises solution, it's like having your own car. You can customize your own car with the choice of your preference without limit. You also get to choose your destination and route. The IaaS model is more like renting a car. You don't have to buy a car, but you can borrow it for as long as you need. You drive the car, and you decide where you want to go and what route you want to take. But you can't change the parts of the car. The PaaS model can be compared as a taxi. You don't just get a car, but also a driver to drive you to your destination. You can decide where to go, but you have less control over the route to the destination and driving style. Finally, SaaS is more like taking the bus. It's the cheapest way to get to your destination without having to do anything, but you don't have the freedom to change the route and the stops along the way. which is very similar to using SaaS, which is using finished software. Next, let's look at the examples of major service offerings and products by cloud model. For the SaaS model, data, web services, web office, etc., are the main services, and representative products include Google Docs and Hancom Docs. For PaaS, development frameworks, middleware, and OS are the main services, and Google Web Engine, Microsoft Azure's pivotal services, and K-PaaS are examples. Finally, the IaaS model provides servers, storage, and networks as services, and Amazon Web Services, Google Cloud, Microsoft's Azure, and Korea's Naver Cloud, KT Cloud, and Naver Cloud Platform are representative products. Cloud computing services are categorized into public, private, and hybrid clouds depending on where the infrastructure is located and who operates it. First, public cloud, also known as open cloud. It is an IT infrastructure such as servers and storage built by a service provider and used by companies for a fee. It's open to an unspecified number of people, and services are accessible through a web browser. It is often used to provide web-based mail, office applications, and storage test development environments. Next, private clouds are also called private or closed clouds. This is when a company builds a cloud environment in its own data center. Only certain companies or users can access it through a designated server or path on a restricted network. It's often used by mid-sized and large enterprises, public organizations, and financial institutions where security is important. Hybrid cloud is a combination of public and private cloud, or combination of cloud and on-premises environment. Rather than moving entire workloads to the cloud, a growing trend in cloud adoption is to use a hybrid approach, leaving sensitive data on premises and using the cloud for workloads that are less security critical or have unpredictable traffic, such as event services. First, public clouds can save you money because you don't have to buy hardware or software and only pay for the services you use, and they can save you time because the service provider maintains the cloud services. Public clouds are highly reliable because resources such as data, functions, and servers are authorized or isolated for each user in each service, so there is no interference between service users, and a vast network of servers prevents failures. They also have nearly infinite scalability because you can use resources on demand to meet your business needs. Examples include Amazon Web Services, Google Cloud, and Microsoft Azure. Next is the characteristics of a private cloud. The advantage of building your own cloud environment is that you retain control of the resources, so you can customize cloud features to fit your individual customer's situation. Also, a private cloud doesn't share resources with other users, which allows for greater restrictions and security. Finally, since you're essentially building a cloud environment, private clouds are also more scalable and efficient than on-premises environments. Some popular products include OpenStack, Eucalyptus, Nutanix, and CloudStack. Third, let's look at the characteristics of a hybrid cloud, which uses a combination of public and private clouds or on-premises environments. A private cloud is controlled by the business, allowing them to maintain their own infrastructure and critical data. Public clouds are also efficient because you only pay for what you use, and they allow organizations to migrate workloads gradually, saving time and money when switching clouds. Popular services for building hybrid clouds include Amazon Web Services Outpost, Microsoft Azure Stack, and Google Cloud's Synthos. Multi-cloud is both similar to and different from hybrid. As we've seen, hybrid clouds are different types of clouds. It's when an organization uses a combination of public and private clouds, or a public cloud and an on-premises environment. Multi-cloud refers to the use of more than one type of cloud. For example, if a financial organization uses an on-premises environment to store and process sensitive information within its affiliates, and a public cloud for information that needs to be shared between affiliates, or for high-traffic, customer-facing services, this is a hybrid cloud approach. Secondly, if you have computing instances in Amazon Web Services EC2 service, and specialized AI or big data applications are imported from Google Cloud, you can say that you are running a multi-cloud environment. Let's compare the advantages of both types. The hybrid type can be operated according to the importance of the information, with high priority information in a private cloud to increase security at a lower cost. Businesses can choose the platform that delivers the best performance based on their computing needs and network environment. They also have the freedom to fine-tune application and data governance and decide whether to utilize local computing resources or the public cloud based on regulatory, security, and other considerations. If you have a heavy workload, you can handle it in the public cloud, which can save you a lot of money compared to using a single private cloud. And if your ultimate goal is to move to the public cloud, but you need to keep your on-premises data center for now, a hybrid type can be a great option. The main advantage of a multi-cloud is that it compensates for the risks associated with using a single cloud, such as unexpected downtime or service interruptions. In addition, cloud providers are constantly investing in developing new products and services, so multi-cloud allows you to take advantage of new technologies as they emerge to improve your own services. And by comparing multiple cloud services, you can find the best price-performance combination to reduce your total costs and choose the best cloud hosting provider to meet your needs based on your business strategy. Both types have their own advantages and disadvantages, and no type is superior. So it is very important for companies that want to adopt the cloud to analyze their needs according to the nature of their business and choose the appropriate type. Part 2. IaaS model. Now let's take a closer look at the model-specific features according to the scope of cloud service delivery. First, let's take a look at the IaaS model for IT professionals to deliver applications, security, databases, and operating systems in a cloud environment. IaaS is a model where computing resources, such as CPUs and hardware, are provided as a service over a network. It is a cloud service that provides the infrastructure. Examples include Amazon Web Services, Microsoft Azure, and Google Cloud Compute Engine. The hallmark of the IaaS model is that it provides a flexible infrastructure by virtualizing physical resources. As illustrated in the textbook, in a traditional architecture, an OS would be installed on a single physical device and applications would run on it, and each organization or individual would have to own or rent that device to use the infrastructure. In a cloud-based environment, however, data centers are built to provide a virtualized environment of multiple physical servers. As a result, the cloud service provider is responsible for and manages everything needed to run the servers, including network, storage, and power. Next, we'll discuss virtualization technology, which is at the heart of cloud computing. Virtualization technology means abstracting physical hardware into logical objects. There are two types of virtualizations: hypervisors and containers. The hypervisor format is based on hardware virtualization technology. A single host computer's resources are shared virtually, allowing a single host to support multiple VMs. As shown in the figure, there is a hypervisor that controls the VM's individual guest OS, are configured with BIOS, virtual CPUs, virtual memory, etc., to appear as if they are running on a physical server, and each VM has applications and associated binaries and libraries. On the right is container. Instead of virtualizing hardware, containers share a kernel, which allows you to construct a virtual environment without booting OS. They leverage the capabilities of the host OS, typically a Linux operating system, to isolate processes and control their access to CPU, memory, and disk space. Individual containers contain only the application and its libraries and dependencies. Let's compare the hypervisor and container methods of virtualization by looking at the table from the textbook. As previously discussed, the hypervisor format has a hypervisor on top of the hardware, which is a platform for running multiple virtual guest OSs on a host. This is sometimes called a bare metal hypervisor, and it sits directly on the hardware and partitions it into multiple VMs, each of which has a guest OS, just like a real physical computer, on which you can install your own execution environment and applications. Next, containers can be used on host hardware by installing a host OS, such as Windows or Linux, and then installing container management software. The container management software leverages the capabilities of the host operating system to isolate processes and control access. Each of these controlled spaces is referred to as a container. A container consists of an execution environment, such as libraries required by an application, by isolating processes without an operating system. Hypervisors virtualize an entire OS environment, while containers create multiple OS environments on a single host OS. Let's look at the pros and cons at the bottom of the table. Hypervisor type virtualizes the guest OS, so the image size is large and requires a lot of resources. It also requires minutes of running time. Containers, on the other hand, are virtualized without a guest OS and use only the necessary resources of the execution environment, so each container requires only seconds to run. In terms of security, hypervisors are more secure than container virtualization because each VM is fully isolated since it is hardware-level virtualization. Containers are process-level isolation since they use the same OS. If the host OS is hacked, all containers can be accessed, making them less secure. In this article, we'll talk about the major IaaS providers based on their delivery method. Public IaaS includes Amazon Web Services, Microsoft Azure, and Google Cloud, while private IaaS includes OpenStack, Eucalyptus, and CloudStack. Then there are the platforms used in hybrid environments that combine the two. Amazon Web Services Outpost, Google's Anthos, and Microsoft Azure Stack Services.